Good morning, students. My name is Abhishek Sachdeva. I am from Lalpur Khalsa College of Engineering, Department of Civil Engineering. And students, this is the lecture for civil fourth semester class, and the subject is concrete technology. So, students, as we are discussing the placing of the concrete or the production of the concrete, the various steps involved in the concrete production and placing. So we have earlier discussed the various steps which are involved. Considering the steps, we were discussing the placing of the concrete, and the placing of the concrete basically applies when we are going to dump that concrete, when we are going to pour the concrete into the various sections which are having the formworks. So the concrete, it is being poured into the formworks so that it may be properly uh, dumped into the sections. It may be properly compacted and vibrated into the voids, and it gives us the proper finished surface. So if we are not placing the concrete in a proper manner, the concrete sections will be subjected to the various defects, and being improper placing, being the improper vibrations, if we are not handling the concrete while placing the concrete, the various voids they may be generated, the defects in concrete, which are the defects of the fresh properties of concrete such as segregation and bleeding may occur, which will result in the development of the non-achievement of the required desired strength, which will again will be the problem when we are going for the testing of the concretes and we are not getting the desired strength. Then we need to demolish that particular sections, and we need to cast it again. So placing, transportation and placing of the concrete to the site at the particular location where the sections they have to be concreted, it should be taken care of. Now when we have dumped the concrete into the sections, the most important factors which is required at particular time is compaction of the concrete. So placing of the concrete without the compaction will not complete our target. Our target is to fill all the sections with the concrete, even when we have tied up the formwork around the reinforcement bars. So if we are not properly compacting the placed or the poured concrete into the section, then the concrete will not move inside the various bars. It will not be properly filled in the clear gaps or the clear cover which is provided around the reinforcement, which will provide, which will on later stages provide the resistance to corrosion, provide the resistance to the corrosion. So if we are not properly compacting the concrete, it will not be filling up into the voids, into the spaces, and due to which there will be the deflects in the concrete, and the uh, durability of the concrete will be hampered. So for this, to avoid this, we need to compact the concrete. Compaction of concrete is the process adopted for expelling the entrapped air from the concrete. So in this process of mixing, transporting and placing of the concrete, air is likely to get entrapped in the concrete. When we are mixing the concrete, when we are transporting the concrete to the site, and when we are placing the concrete through the pumps, through the pipes, or by manual means to the sections, so it is possible that the air get entrapped into the concrete. So entrapped air may uh, disturb the formation of the concrete and disturb the achievement of the required strength of the concrete. So it has been found from the experimental studies that 1% air in the concrete approximately reduces the strength by 6%. As I have discussed, when the entrapped air will come into the concentration in the concrete while during the placing the concrete into the sections, it will reduce the strength. If the uh, ex- uh, if the entrapped air is more than the 1% or 1% of the entrapped air in the concrete, it will reduce the strength, compressive strength, and even it will affect the durability. And that's why the compaction of the concrete is done, so that the entrapped air is removed and the voids they are being finished, and the sections they are being properly filled with the concrete. So if we don't expel the air, it will result into the honeycombing and reduced strength, and further reduce the durability and the lifespan of the concrete. So it is very essential for the concrete to be compacted after placing into the sections. And for compaction purpose, we are basically using various types of the vibrators, different categories of the vibrators, so that depending upon the section, depending upon the depth or to be compacted, various equipments they may be adopted at the site for the proper compaction of the concrete. So these are the different methods which I was discussing, the methods of concrete compaction. The first one is the hand compaction, which is done by the rodding, ramming, and tamping. When basically we are mixing the concrete, right? If the work involved is of less importance and a very small scaled work is involved, for that particular type of the work, we can go for the hand compaction. But when the quantum of the work is more, when the quantum of the work is more, then the compaction is by the mechanical means. So internal vibrators they can be used, which for which we are providing the vibrations. See students, compaction is basically compacting the concrete in such a way that the entrapped air is removed, right? So when we are compacting, it may be with the vibrations or it may be the non-vibration compacting. When we are going for the hand compaction, then vibration produced within the concrete is less. No vibration is produced because we are tamping the concrete and we are ramming the concrete. We are not providing any vibrations, but tamping or the ramming itself provides a certain amount of the vibration in such a manner that the entrapped air is removed from the concrete. So basically, when we are talking about the proper compaction of the concrete for the large scale work, or where the work involved is of the large quantity, then the vibrations they are essential, and internal vibrators, formwork vibrator, table vibrator, platform vibrator, surface vibrators, they are used for the compaction by the vibrations. So basically, hand compaction is basically applicable when we are mixing the concrete in a very small quantity, and when we are filling the concrete cubes or the cylinders or the beams for various tests on the concrete. So hand compaction can be adopted at that particular situations and at the sites where the concrete produced in is of the less quantity. So basically, when we are testing the concrete, when we are filling the various specimens for the testing of the concrete, generally the tamping or the ramming or the rodding practice is done for the specimen, and the samples they are being casted for the testing. So when the quantum of the produced concrete is large, for that the vibrator plate is used. We can cast the specimens also by keeping the specimens on the vibration plate, and for the construction sites also we use needle vibrator, we use the formwork vibrator, which is depending upon the depth of the sections. The table plates vibrators are used, the platforms are used so that the concrete is properly compacted and the entrapped air is removed. Now, students, the next is the curing of the concrete. See, we are discussing the concrete production and placing step by step. Initially, we are mixing the ingredients of the concrete as we have discussed previously. Then we are basically uh, producing the concrete, and after that, the transportation of the concrete, and then the placing of the concrete. So, the complete process will be done after the curing of the concrete. So we are going towards the finishing part. The concrete has been poured, it has been compacted, all the air voids have been removed, and after that, these sections in which the concrete is dumped is completely filled up with the concrete, and the surface has been finished. But the achievement of the strength, the achievement of the desired strength of the concrete has not been taken place because it requires the proper curing. If the surfaces or the sections which have been casted for the concrete are not cured properly, then it will not attain the proper required strength, and it will be subjected to the contraction and the expansion pertaining to the considering to the environmental impacts. So basically curing is the process in which the concrete is protected from loss of moisture and kept within a reasonable temperature range. The result of this process is increased strength and decreased permeability. Curing is also a key player in mitigating cracks in the concrete, which severely impacts durability. So basically students, we have earlier studied the reactions of the concrete. So reactions of the concrete, they are in the presence of the water content. So if the concrete, it will not be subjected to the required desired availability of the water, then it will not be able to enhance the reactions within the concrete, and due to the loss of the hydration, due to the loss of the hydration, loss of energy during the hydration process of the concrete or the cement, the requirement of the external source of the water is very essential when we are going for the casting of the various sections from the concrete. So basically, the curing is one of the essential parameter, so that the concrete, it may able to attain the desired strength and durability, and it will not be subjected to the cracks. So when we are not providing the adequate quantity of the curing or adequate quantity of the water to the sections, then it will be it will be decreasing the strength and the permeability. Permeability will be increasing and the strength, it will be decreasing. So curing, proper curing is very essential for the sections of the concrete. So curing can be defined as the procedure for ensuring the hydration of the Portland cement in newly placed concrete. Reactions of the cement, that is the C3S and C2S, the compounds of the cement, tricalcium silicate and dicalcium silicate, they will result in the gain of the strength, and the water is required. As C3S, it will be reacting with the H2O, and C2S again, it will be reacting with the H2A, and we will be getting the calcium silicates and hydrates. And the quantum of these reactions are strong, and it can be enhanced if the proper amount of the curing is being done on the side for the sections which are being casted for the concrete. So it generally implies control of moisture loss and sometimes of the temperature. Need for curing causes hydration reaction of the cement with water. As I have explained you, the compounds of the cement, it will react with water to give us the calcium silicates and hydrates, which will impart the strength to the concrete. If the proper quantity of the water is not applied to the concrete, then the hydration reaction will be poor and the decrease in strength may be expected. Loss of water by evaporation can be prevented. When we are properly curing the concrete, the loss of water, it can be prevented, which can be conducted through the evaporation processes to maintain conductivity temperature, for completing of hydration reactions, and for capillary segmentation. So students, basically the durability factors, it may also be enhanced or affected by the improper curing. So when we are not curing the sections in a proper manner, the water will be evaporating and the voids will be empty and it will be subjected to the cracks. So hydration reactions, they are important, and the proper maintenance of the conductive temperature is very much essential. So in that case, the concreting, it has to be properly cured. So there are the certain methods of the curing, which includes the immersions, pounding, spraying, covering with wet sand, wet Hessian, that is gunny bag, membrane curing, and waterproof plastic sheeting. So basically, these are the different methods which are adopted. We can immerse the sections into the curing tanks. If the sections are the precast sections, pounding can be done. That means the sections may be subjected to the direct contact of the water by placing the water within the sections for a certain period of the time, and it will be like the stream. We are basically supporting the various corners. We are providing the shuttering to the various corners, and the water is allowed to stand in the particular sections. Spraying with the water can be done. Wet sand, we can cover the sections with the wet sand, and we can sprinkle the water over the wet sand so that the water is properly available for the sections, and we can wet the gunny bags, that is wetted hessians. We can wet the gunny bags, we can dip the gunny bags into the water, and that gunny bags, they are being placed over the sections which require curing, and proper wetting of the gunny bags is to be done, so that the amount of quantum of water which has been absorbed by the gunny bag, it is properly curing the sections. Membrane curing and the waterproof plastic sheeting can be done on the sections which require curing. These are the various methods of curing. So last and the final step which is involved in the production and the placing of the concrete at the various sections is finishing. This finishing can be strictly functional or decorative. Finishing makes concrete attractive and serviceable. The final texture, hardness and joint pattern on slabs, floors, sidewalks, patches and driveways depend on concrete's and use. So basically, after the proper curing of the concrete, the finished surface is available to us, which can be basically strictly functional. So we can go for the various finishing of the joints and the patterns and the textures of the concrete surface, and which is not having any relation with the strength gain or the durability factors, but definitely it will be giving us the attractive and the serviceable concrete. So students, this is the whole procedure of the placing, production, placing and the finishing of the concrete, and these steps, they are basically involved in the whole concrete setup in the various sections and production and its final finishing. Thank you.